Okay, now when we get to the test, you've got to be able to do all these calculations for limiting reactant, theoretical yield, percentage yield, excess reactant remaining for both single replacement reactions and double replacement reactions, or combustion reactions. So there's three kinds of reactions that you would have to do all that for. All right, now I can do a double replacement reaction for you now, which is like what you're doing in the lab.
Yes.
Or I can do one of those other kinds of reactions to give you some practice with that. You want to do a double replacement reaction?
Yes.
Okay.
All right.
Well, I was looking. Oh, I know I stuck them up here. Here we go. See, what's today's date?
26.
26th.
That's my football number.
Okay, I have a birthday in another class. I need to make sure I remember. Let's see here.
Tom, you're not winning this, Tom. You're not winning it. Don't smile, Tom.
Write this down as I work, please.
I win.
She's got chemistry shoes on. Whoa.
Yeah, my house. Tom, tell Tim I said that. Why not? I'll just text him myself and say, hey.
Ooh.
Not you.
Ooh.
I do have his number.
911.
It's 864 101
That's a 98.
91.
Terrible.
What's you? Who was that? Was that Bill?
Definitely Bill.
Misha, that sounded like a mole. Cat mole.
You sound like a football person.
Yep. I bet it's Kaylee. This is gonna be a doozy.
Mm-hmm.
Is this gonna be like an extra credit problem on this
No?
Mr. Taylor, when you get done writing this, I gotta ask you something. It's real cool.
Uh-huh.
Let me know when you're done writing.
Your boy.
Hey Tom, spell silk.
S-I-L-K.
Faster. Faster.
S-I-L-K.
Faster.
S-I-L-K.
What do cows drink? They drink water.
It's really bad.
Tom,
That's
Tom,
childish.
Why do you say childish so much? It's like
Tom,
your
don't
favorite
stop.
word.
Tom,
I always
No,
talk
stop.
right.
I think you're
So,
childish.
y'all are
Saying
childish.
childish.
no, that's too easy.
That's really good. Brian, say so.
So let's see. We've got strontium chlorate. Strontium is Sr. Chlorate is ClO4. If you don't know anything about those, you can always look those up on the periodic table for strontium. Chlorate, the ATE ending, ATE and ITE endings tell you right away it's a polyatomic ion. So you can look that up on the common ions list. And by the way, chlorate is ClO3, not 4. ClO4 is perchlorate. I'm sorry.
So ClO3.
ClO3 is chlorate. Okay. And chlorate, where is that?
It's on the left side.
Is it? Okay, there it is. Yeah.
Side.
Has a 1 negative charge. And strontium, if you look on the periodic table of oxidation numbers, has a 2 plus charge. It's right here. Okay. So if I need to have I need one of these and 2 of these to balance the formula to get a neutral compound. So this formula is SR, parentheses, ClO3, parentheses 2. And then we're going to react that with, it says, magnesium sulfate. They're put in the same solution, just like in your lab. This is kind of what you did in the lab, isn't it? Okay.
Just a little bit.
So we got magnesium. That's an element. You can find that on the periodic table. If you look there, you'll see magnesium has a 2 plus charge. Go to the common ions list, and sulfate has a 2 negative. Well, that's the wrong list. There you go. Sulfate has a 2 negative charge. There's sulfite. Where's sulfate?
Right there.
Right above.
Right above it. Right up. Up.
Oh, sulfate. Right
There
there.
it is.
So that means I got a 2 positive and a 2 negative. This must be balanced with just one of each. Okay? So we want to find out what our products might be. We need to know what kind of reaction is likely to happen, or at least our first prediction of what will happen. Well, both of these are ionic compounds. Okay, if you've got 2 ionic compounds, the most likely reaction that you can predict at this point in your career is a double replacement reaction, where the front part of this goes with the back part of that. Yes, it is your career. Okay, and then magnesium is going to go with chlorate. Okay, and we need to balance these. Now, a moment ago I said strontium has a 2 plus charge and sulfate has a 2 negative charge. So that's the correct ratio there. And I said magnesium was 2 plus and chlorate was 1 negative. Alright, so this I need 2 of these over here. Okay? Anybody have any questions about that so far? Alright, so we need to balance the overall equation. Actually, we probably ought to determine if we have a driving force first, because if there's no driving force, we don't have to do anything else.
Yeah.
Alright, so we need to go to our solubility rules. We said that these 2 were dissolved in water, so you know already those are aqueous. You don't have to really even have to look those up. Unless I really messed up, you'd assume those are going to be aqueous, okay?
You never messed up, Mr. K.
I mess up all the time.
Nuh-uh.
I have to double check my work all the time.
Nice.
So let's see, here's strontium and sulfate, and it says here that sulfates are in the soluble section. So if there's water around, and we know there is water in the problem, if there's water around, something that's going to be soluble is going to be aqueous. So sulfates are mostly aqueous, except when they're bonded with, well, there's strontium.
Oh.
So that has to be not aqueous, but solid. Chlorates, it says up here that all chlorates are always soluble. There's no exceptions. So this is going to be aqueous. Okay?
So we have a driving force.
We do have a driving force. Okay? And we need to balance the equation. So what do we use for balancing an equation?
Yeah.
Add inventories. Y'all been doing that for a month now, so you should be able to do that, right? Good.